view models should not know about each other. Because that limits reusability, that makes spaghetti code in your application, and different presentation requires different code, and then the control flow I don't like all three statements. I think it's very confusing and very error prone. And if you have the same view being presented in different contexts, yet another if statement. And then you also have to store states to understand what the context is, which is very complicated. And testing is much harder because you need to stop all of your dependencies. So this is where flow coordinators come in, and I have an article about this called Improving Architecture with Flow Controllers. And there is an article from Kanlu about the same concept. We basically, when I wrote it, I called it flow controllers, he called it coordinators, we now call it flow coordinators, basically. You can read both articles. But there is something I've been using for many years, and Suresh as well. So this is how it looks like in simplicity. You have this one object that coordinates how your view controllers and views are related to each other, and that way makes the dependencies flat and the injection much simpler, because that flow coordinator now contains something has to know, right? Something has to know how the app is connected. So the flow controller volunteers to do that. It volunteers to know what are the main dependencies of your application, but then when it creates each of the view controllers, it injects just the thing that it needs. So now when you look at your view controllers, you don't actually need to know how they are connected, what happens in the flow here. Because when I analyze in this one, I want to see, okay, it relies on this single dependency called D, and those are the triggers that it has. So a trigger would be like a button, like a done button was tapped, or a cancel button was tapped if this was like an edit profile screen. So those are two exit points for the view controller, and then I can need a flow coordinator and connect it together. And this lack of knowledge makes it much easier to test your view controllers and view models in separation. And the thing here, I have the arrows going up, but the way I usually structure is, none of those things actually know about the existence of the concept of flow controllers. What I do instead is I have closures that I can inject into each of them, and then the flow coordinator can inject the presentation. So for example, if this is edit profile, then I have on done and on save closure that's created when the object is initialized. The flow coordinator will say, okay, if it's cancelled, then don't save the coordinator context. If it's saved, then update the coordinator context. And also dismiss in both cases, right? And it knows how to dismiss it because it also presents it. So if I show this from one context, which might be on iPhone, I know it was presented by pushing that navigation stack, so I have a function that does the iPhone version, and then I have a function that, or a different flow coordinator that does the iPad version, which shows me a popover. And it's a different code that executes, and there's no if statements at this level, which makes it much easier to understand. So the flow coordinator creates the view model and view controller, configures it based on a specific context. For example, image picker might be shown from static screen differently than from create post in an Instagram-like app. And based on the context, might be iPhone, iPad, or whether it's contained as a child view controller. And it also listens to the events from VC and view model, whether through closures or through observables. It's up to the architecture. And it can inject all the objects needed to fulfill the role. So all the dependencies and configuration gets injected. That means that you don't need singletons. Because at this point, dependency injection is very simple. And it makes no sense to create shared objects because it's flat. It doesn't require you to add dependencies to n, like multiple objects in a chain. Rather than that, the flow coordinator has the main objects, and then it's a single function that creates each of the different view controllers, and you can just inject it directly. And there's no pain associated with doing that. So an example might be something like this. When a state might be a view, whether it's a view controller or a model, doesn't matter based on your architecture. In my case, that should be a view model, so it's called view model of the state. But in the case of dependency, I usually also have an object which represents some kind of data state. And I store it in this structure, for example. And then I have a program closure, and I just inject what happens when this happens in this view. So if I have a button called add program is connected to this closure, it doesn't know what the closure does, it just calls it. And now I can present another screen, makes it much easier. So with MVVMC, you have your view models don't know about the presentation, it doesn't care. There is no UI kit involved in view models other than the model objects. So the only thing that they usually see is images. You could extract that, but it makes no sense. You can just use UI image, it's fine. And a black box interface for all the triggers, which means that it doesn't know about flow coordinators, it doesn't need to know about flow coordinators. And that makes it extremely easy to test and very usable. Because when I do this, my coverage gets to like 80% for the whole app. That's a very good test coverage for an iOS application. And when I get a bug report from the client, I can just reproduce it without ever having to create the view. I can just reproduce, because all the logic is in the view model, the views are just rendering it, right? So if I have bugs, it's usually in the view models, so I can write a test that reproduces a bug before I fix it. Then I can run it, see that it's red, fix it, see that it's green, and have the confidence that it doesn't happen again in the future. Because I just improved the code coverage, which is awesome. And when we talk about the UI architecture, right, but the data architecture is at least as important. So let's look at how I like to set up it. And this goes back to being blocked. Like a lot of times people say they're blocked because the API is not ready. And if you have the data architecture set up with composition as well, it makes it much easier to never have to say that I'm blocked. In fact, most of the time what happens is I implement my part, so the iOS part of the feature before the API is near completion. And that is pretty cool, because then I can do more important stuff for the project. So one of the most important things I think that you have to do is you have to think about your data processing as a pipeline and use protocol at each stage. And an example might be a data provider that gives you raw data. So it might be just getting a JSON. Then you have a decoder that gets from untyped stringy data to proper strong types. So you use codable here, you can use anything else to create your models, whether it's core data, it doesn't really matter. Then you have the model converter that it actually, it gets all of that together into the objects that you use in your business logic. And then you have the consumer of those models, which is a view model, which is some kind of controller that you have. So this is how it's connected, right? Very simple, just simple composition. Things are connected in a pipeline. The pipeline allows you to do a lot of nice things. So let's say you want to write tests for your view model, or you have a bug report that requires very specific data configuration. So with the pipeline, you can just replace the model converter with fake data. So you just specify the models there. You just skip touching all of the other code. You don't need to ask your API guys to create a staging information that simulates the data that is broken for this specific bug report, because in big companies that's going to be hard for each bug because there's so many bugs, and the staging, you usually have one staging. And so just injecting the data directly into your tests or into your application if you don't do tests is very convenient. And it works great for static data. It doesn't really work well for testing mutation problems, but you can do something for that. So let's say you want to test, you already know that your app can display data, like you have fake provider, and it just gives you a single set of data. And you display it, and you see, like for the types, it's the articles. So I see the first articles load correctly, it lays out correctly, and it seems to work. But I cannot verify mutation, and mutation is something that causes the most amount of bugs, by far. It's not the initial load, it's usually when the state changes over time that you end up with problems. So we want to be able to easily load external application, like external data to our application. If you are running on simulator, we can load this from a desktop file on our Mac. But if we're running on device, we want to load it from network resources. And we want real-time updates so we can simulate conditions. So we can simulate the data changing on the server. So I wrote a tool for it, very simply, and it's called File Watchers. It just exposes two objects, which is a local and remote observer. And this took me like 3 hours to write for the times. It's open source. You can find it on GitHub. But the reason I mention it is with the pipeline architecture, the way I designed it, this is the only thing I had to do. It literally took me 3 lines to connect this to our architecture. And now we have this thing. We already had the decoder, we already had the converter, we already had the view models. But what we didn't have working servers. So we didn't actually have the way to get the real data in. So what we did is we downloaded a huge JSON file, like I'm talking megabytes of JSON, which was terrible. Trust me, it's terrible. And so I connected it in 3 lines of code with the file watcher, and I could test the whole processing. Outside of the single raw data provider that we normally would use, that part I couldn't test here. But this is how it looked when we did it. So on the left, I have a JSON file. On the right, I have how the Times app looked 2.5 years ago when we were rewriting it from scratch. So this is how it works. I have this file on my desktop, and I edited Visual Code. And I can see the changes happen in real time. And this, this was very helpful because our servers were nowhere near ready. I think the actual servers were done months after this was finished. And so as I am changing the JSON, I can see our implementation being updated, right? So the thing here is just changing the value, that's simple, right? But this actually re-renders the whole thing. So if I change the type of the article, a different layout will appear. We still have very little layout here. But that allowed us to significantly improve our efficiency. It allowed us to implement all the different nodes, all the different UIs for articles, and test them before the servers were ready. So when the API finished, we were able to just connect to the real API and see everything working, which was very helpful. So that's why I structured the architecture like that. I want to mention, just before I wrap up, interesting architecture approaches that I've seen, and what I really look forward to is architectures based on Redux or Elm, which are unidirectional data flow, and they're based on pure functions and single source of truth, which is the Redux approach. And I want to mention it because it's amazing for dev tooling. So with unidirectional data flow, what happens is you have this flow of the data. Like this is just a composition, so this is really how it looks like, and it's a single direction, which means that you can add a lot of cool things to it. So for example, you have the state. In Redux, this is just a single source of truth, which might be a database, it might be a structure, depending on the complexity of your application. What's cool about it is it only mutates through actions. So what can happen is you can record the actions, save them to JSON, store them on the server, and then you can replay them. So imagine you have an app using this architecture, and you have a bug report. What can happen is with each bug report, you can actually store all the actions that the user did, and then load it into your application directly. So rather than having to figure out what happened from the logs, or the information that the user gave you, which they never gave you the right information, you get all the data they had, and you get all the actions they did. And you can replay it while being connected to a debugger, which means you can also do it with crashes. And with crashes, you just jump start to the last step before the crash. You load that state, and then you just go forward and you crash. And this is how time travel works. Those are actions that are recorded, and you can just move the time. And you can see what the user was doing. And this is really amazing, because it allows you to reproduce bugs and crashes remotely. Doesn't matter where it crashed, doesn't matter what kind of information the user gives you, because you can record it. And it also allows you to use code injection to do hot reloading. So if you have a single star and you get to a specific action in your project that requires a lot of manual interactions, like going to this screen, filling this text field, changing some status. Normally, when you change implementation, you have to restart your application, and you have to do all those things again, right? A lot of manual labels. With an architecture like this, you just hot reload the last view controller with the same state you had before, and you can just keep iterating on it very quickly. So this is something that I'm looking forward to. Like There are problems with this approach on iOS still because UI kit is imperative, it's not functional. So expressing this has some, some issues, but there's a lot of different projects working on this. And there's also projects that are working on making UI kit more suitable for this. There's like a thing called render that goes from data to diffing UI kit and making it efficient, which is also interesting. So let's summarize some of the things I said, because it took way longer than I expected. There's no silver bullet. Each project has different requirements, and that will lead to different architecture choices. Like I like MVVM and I like coordinators, because I think for a lot of projects, this is a good default to start with. But I also think that this is not the best architecture for everything. In fact, I made apps. For example, I made an app called Zabłocki, which is a Premier League app that used runtime to figure out the architecture. So what happened is there was a JSON, and you had widgets. It was a real-time application because you wanted to get goal information and like league tables for Premier League, all this stuff very quickly. Hasn't changed. How it worked is we had a JSON format that was basically two fields. One field was the type of a widget that we want to display, which might be a goal, score, table, whatever. And the other type was called payload. The other value was called payload. What happened in the architecture of the application was that the core of the app would parse those JSON objects. It would just read the type, and then it would use runtime, because it was back in Objective-C, but you can still do it in Swift. It would use runtime to find all classes implementing widget model protocol. It built that list of classes, and then it would ask those classes whether they support this specific type of a payload. If they did, they would get the payload information, which the core doesn't care whether it's in, right? They would parse it, turn it into real types, and then we would find the views as to display that again using runtime. We would ask for the widget view model, and then widget view protocol, and then that would reply to us whether it supports this specific model. If it supported that model, it would just get that value, and then it can be displayed in the architecture in the app as a widget. And that worked amazingly. It's not, it's not like when people hear runtime, they are like, oh my god, so risky. This was amazing because it allowed us to scale in the amount of developers that work on the project without limitations, because they never had to touch the core. We never had merge conflicts for a year or something that we developed this. We had never run into merge conflict on the core of the application. Because if you wanted to create a new widget, you just had to conform to those protocols, and then the app would pick it up using runtime. You never actually had to register manually. You never had to add if statements or connect the classes directly. And if you wanted to disable a widget, you just select the files related to the widget, and you just uncheck the target that the else gets. And then after we finished this project, they hired us to do 2 other applications for different sports. And we managed to do them in 2 months by just reusing the architecture, reusing some of the widgets and making some of the new ones very quickly. So I did this similar approach using runtime for a press publishing platform before as well. So there is definitely no silver bullet. And in those situations, using the regular MVVM or Viper or something like that would be not as good. It would work, you could do it. But this made us very fast, very efficient, and also allowed people to work in separation and allows more flexibility. Because you could implement the widget in MVVM or MVC or whatever, depending on the complexity, as long as the core objects that started everything up would follow the protocols, do whatever the hell you want. And it worked well, very well. So testing is something that will definitely give you benefit. A lot of benefits. If you learn how to do testing properly, it will make you a more efficient developer. Obviously follow solid principles, like I probably don't need to say that. And remember to make it simple, make it flexible by making it simple, not by over-engineering. And I always mention this one story. My friend and I, like everyone, I used to game for like 10 years. And back in my younger years, everyone was doing game engines because Unity didn't exist. We didn't have those kind of things, so we were building game engines. And I had a very different approach than one of my friends had. My friend was making also a 3D game engine, but when he approached a problem, he would solve it for every possible permutation. So he was doing, one thing that comes to mind is, he was doing collision detection for his game engine. So rather than using the basic colliders that usually have like sphere versus sphere, sphere versus box, he would do all the permutations, convex versus concave shapes, all these things, right? And he did it for everything, not just for the collision. So he wrote this awesome game engine. He then did a demo. He open sourced it, so it was like free for commercial use and everything. He open sourced it. He had like 6 or 7 games, as an example, written in. One of the games was like a Pac-Man game in 3D. And then he gets hired to make a commercial game. That was basically his Pac-Man demo, except the Pac-Man was a fish. That was a game for kids. Very simple game. It looked exactly the same. And the funny thing is, and I kind of did, this was like 12 years ago, and this is something that stood in my mind. You know, you just spend years making this game engine, and it has support for everything. It is so flexible. It has so many different abstractions to solve all your problems. And even you get hired to make this application that is very similar to what you just did with the game engine. What do? You write it from scratch because it's so fucking complex. So, don't over-engineer stuff. Try to make it flexible because it's simple, because it's easy to understand, and because when you look at it, you know what you need to change. Not having hundreds of protocols for each different domain in your project. And also, what's very important is you have to think about developer experience when you design your architecture. Because the way your day-to-day work will look, how it will look, it will affect your team efficiency. If you make an architecture that makes it really hard to add new features, people will feel pain when they do it. They will try to avoid pain. People try to avoid pain at all costs. So for example, let's say you want to add a new feature, and that requires you to code generate 5 different or 6 different classes. There is an architecture that does that. And some people like it, some people don't like it. Don't, try to avoid that. And for example, we had a teaming in our application with the types. A teaming support, so you can dynamic type, different colors, all this stuff. And the first version of the teaming contained primitive values. So you would have a font, a color, a line height for each element in the application, which in an application like ours, which is a news application, means those elements will exist in like 100 permutations, because different articles would have different permutations. And so now you have a team that contains 1,000 primitives. And now let's say a designer decides, well, I actually want to add a paragraph style to this specific object. So now you have to add a primitive for the paragraph style. You have to fill it in for all different teams. Then you have to go to the view models and you have to change the logic to actually apply this. So to create a paragraph style, apply it to your attributes. But then they also need to add size classes support. They want a different paragraph style for compact versus regular. And now this is a bigger problem because that means that you have like 5 or 6 properties. Now you need 12 properties. So you end up in this situation with adding something as simple as changing line height or changing a font requires you to touch multiple files to add a lot of data, where there are things you can do to make it more simple. So rather than using primitives, I refactor it to use functions. So the team no longer contains the font color, no longer contains the line height, no longer contains the paragraph style directly as a data. What it does is it contains a function called apply whatever style. And that function just contains the primitives directly in code as a function that just runs on string and returns attribute in string. That means that the only thing that the view model does, it calls the function with the argument, which is the text, and then it assigns it as the output. And that means when the designer decides to change it, the only thing I do is I go to that function and I just change the code. I don't touch my view models, I don't touch anything else, I don't need to add another primitive, I just change the actual implementation. It makes it much easier and it's way more convenient. So this is part of the both developer experience and over engineering. You have to consider, things will change over time and you make a lot of mistakes when you start a project. But the thing here is you have to learn from your mistakes. And I have never thought to myself, well, I could have written 20 more protocols for this. But I did think a lot of the times, like, why do I even need this class? This looks like it could be just part of the team. That actually happened. We had objects called stylers, which are useless. They should be part of the team. And slowly we're replacing that. But, learn from your mistakes. In the end, the best you can do is design an architecture that makes the right choices easier than the bad ones, especially in the big teams. There's no way you'll be able to review all the code changes that people are doing. So if you have an architecture that requires a lot of hand-holding, it's really not a good choice, because people will make mistakes. You will make mistakes. It doesn't matter how advanced your team is, or whoever thinks they're special snowflakes, everyone makes stupid mistakes. And you have to deal with it. So think about how you can make life easier in both developer experience and the architecture choices. Thank you. If anyone has questions, I'd be happy to answer them. No questions? Oh, okay.
About the flow coordinators you showed, I was wondering something similar in production applications. Do you like the idea of using multiple coordinators within an app, or is it just one flat coordinator?
No, I think you should have multiple. So the way it's similar to storyboards, right? When you use a single storyboard, what happens is the only thing you end up is a mess, right? If you have a single storyboard for the whole app, it's just going to be a mess. It's going to be a merge conflict hell. So the way I think about both storyboards and coordinators, which I don't recommend storyboards, just as an example, use it for a set of use cases and screens. So for example, in our application, we have authentication flow coordinator, which deals with screens related to logging in, forgetting passwords, or registering. We have comments flow coordinator, which deals with all the flow related to creating comments, reading them, changing the, we have like multiple filters for comments, right? So different screens as well. What else do we have? We have settings flow coordinator, because we have multiple screens for the settings. And now, basically how we structure this is, each app starts with the root flow coordinator. That is how your app starts. And then you can create child flow coordinators, and a child always has a root view controller, and also child has end triggers, similar how the view model has, like you save and cancel, right? The same happens with the flow coordinator. So authorization flow coordinator has basically a closure with a state of what happened. So whether the user canceled the logging in, whether they were registered as a new user, or whether they logged in as an existing user. And based on that, the power of the flow coordinator can make side effects. So for example, there's a lot of actions in our app that requires you to be logged in. So when you try to save an article, for example, we present outflow coordinator, authorization flow coordinator. And as an end trigger, we set up actual saving. So when you press the save button and you are not logged in, the first thing that happens, we change the flow coordinator to be the authorization. Once the authorization finishes and it was successful, we will save the article. So it's basically the parent-child relationship here. Works very well. Yeah. Any other questions?
Do you test your coordinators?
Mm-hmm.
How?
So this is problematic. Like something in your app will be hard to test, right? Because something has to have a lot of knowledge. To make coordinators easier to test, what you can do is you can separate the configuration from presentation through protocols or composition. So what we do is we have a presenter thing that normally in production goes to either the normal view controller model presentation or the push navigation controller stuff. In test, we replace that with a fake. And so we can test that when you configure this view and you call a trigger on that view, something is presented of specific type. So we can test those things. So we test configuration, we test that specific view controllers are pushed. The test coverage is not, it's not crazy, but it's good enough. It's like 40, 50%, which is significantly better than what it was with NPC. So, yeah. Okay. Any other questions? Yeah?
When you were explaining about the coordinators, you made this example with the edit screen. And then you said that different case where you tap done or save. You said that the coordinator will save or don't save based on this action. And I was wondering, is this supposed to be part of the controller as opposed to the coordinator? You said
it can, right? So this is really up to like a specific implementation. Like usually so there's one thing that I always wonder when I do my view controllers or view models. If I have a dependency that I have to inject into it, if that dependency is used, like so let's say I have like a core data, whatever, manager, right? I don't like to inject the core data objects directly. I use plain Swift objects, value types and stuff. And if I have a dependency that the view model needs to call multiple methods on, I would inject the dependency directly, and I would interact with the dependency from the view model. If I have something that, like if I say, let's say I have this manager object, but I ever only need one function from it, I usually actually don't inject that dependency into my view model, because that means that I need to fake all the whole object. What I do is I inject a closure, a trigger, and the flow coordinator just wraps as the closure, it inserts calling that specific function. And what this allows me to do is when I test that specific view, I just smoke this single method. So it makes it much easier, less permutations and everything. So in this edit and save, you can have it in the view model if you are actually dealing with core data or the data storage manager, but it might be that your view is dealing with plain Swift object, it doesn't even know what is used underneath, and so you might actually call something from the flow coordinator that the view doesn't know about. So it's a matter of whether it makes sense from a pragmatic perspective. From the responsibility perspective, we do call the dependencies in the flow coordinators quite a lot, just to avoid, just to increase the reuse and decrease the amount of information that the view models know about. So if I